Hello everyone, welcome back. In this presentation, let's focus on ER diagram for university database. We know DBMS has a widespread application areas, mainly in banking, in university, supermarkets, sales, enterprises, marketing, railways or airways reservation, HR, telecom, insurance, hospital management, and whatnot. All application areas are actually dealing with the real world entities, where each entity is a real world thing or an object which is distinguishable from all other objects. So we can understand that DBMS is inevitable when we are concerned with effectively storing the data and effectively retrieving the data as well as and when required. In this presentation, we will focus on how a university database looks like. Please be noted that this university database may not be suitable for all universities because this is purely requirements based. Universities may have their own requirements. So, this ER diagram, whatever we are going to see now, is just a generic way of representation. However, as I mentioned, this is requirement based. Before seeing the university database, we should have a strong fundamentals about what is an entity relationship model or the entity relationship diagram, how entity sets are represented. A strong entity set is represented with a rectangle, and a weak entity set is represented with a double rectangle. Coming to the relationship, a strong relationship is represented with a diamond symbol. A weak relationship is represented with double diamonds. And we have other notations as well, how attributes are represented. There are different types of attributes. Single valued attribute is represented with an ellipse. Composite attribute is represented like this. Multi-valued attributes are represented with double ellipse. Derived attributes are represented with dotted ellipse. We have null attributes as well. If you are directly watching this lecture, I would request you to watch my previous lectures on ER model and ER diagram to gain better insights and understanding. Now let's step into the ER diagram for the university database. When we talk about university, these two are the important pillars in the university database. Number one, the instructor, because a university cannot run without instructor. And what's the next entity that is also inevitable? The student entity, obviously. Yes, university contains instructors and students without any second thought. Now, if you talk about the instructor entities, what are all the attributes we have? The instructor ID, the name of the instructor, and the salary. This instructor relation may have any number of attributes. Considering the space constraints, I am just projecting only three attributes: the instructor ID, the name of the instructor, and the salary of the instructor. Coming to the student entity or student entity set, we are dealing with only three attributes: the student ID, the name of the student, and the total credits. If you observe, these two are strong entities. You know why? Because they have their own primary key attribute. Instructor has instructor ID as a primary key attribute. Similarly, student also has a student ID as the primary key attribute, so that these ID attributes helps us to identify the records uniquely. Alright, we have seen about two entities, instructor and student. What is the relationship between an instructor and the student? Obviously, it is the advisor relationship. Instructor advises students, or students takes advice from the instructors. So in this example, I am establishing advisor relationship between instructor entity and student entity. And what kind of relationship is that? Can you see this is actually a one-to-many relationship? Because an instructor may advise many number of students, but a student may have at most one advisor or instructor. And that is why the relationship between instructor and the student is a one-to-many relationship. Now, talking about the relationship, it is a strong relationship. You know why? Because this relationship is associated with two entities, instructor and student, which has their own primary key attribute, which is the instructor ID for instructor relation and student ID for the student relation. Fine. I gonna construct the ER model with this way. So at first we started with instructor and student entities which are connected with the advisor relationship, which is a one-to-many relationship. Now let me bring in another entity set, which is the department. If you see, all these are real-world entities, right? Instructor is a real-world entity, student is a real-world entity, department is also a real-world entity. In a university, we cannot think about an ER diagram without department because this is the one where instructor is also associated with and student is also associated with. Every instructor who is hired definitely will be belonging to a specific department or a particular department. Similarly, every student who is enrolled into the courses in the university will be definitely belonging to a department. And that is why we are thinking about the next entity, which is the department entity, which has its attributes, department name, the building, and the budget. As already mentioned, considering the space constraints, I am projecting only the limited number of attributes. Also, this is requirements based, and also this is assumption based. In a generic way, a university will have these many things. Now let's focus on how instructor entity is associated with the department entity. Obviously, there will be a relationship, isn't it? What's that relationship? It's the relationship between the instructor and the department. You can give any name, instructor works for department or instructor joined in department, but in a generic way, I am representing it as instructor department. So this is the relationship instructor department, which is connecting the instructor entity and the department entity. What kind of relationship it will be? Obviously, one-to-many. Can you see here? One-to-many, meaning a department may have many instructors, but an instructor may have at most one department. And that is why this is one-to-many. Is it something additional that you are noting here when compared to the relationship between instructor and student? Yes, something is different here. What do we mean by this double line? Meaning it is the total participation. If you recollect in one of the previous lectures, we have dealt elaborately about the participation constraints. Here, there is a total participation. Can you see here? This double line indicate the participation of instructor entity with the department relation is total participation. What do you mean by that? All the instructors who are working in this university will be definitely belonging to a department. And that is why this is a total participation. Here, my assumption is there are no adjunct faculty or no guest faculties. As I already mentioned, it's all dependent on the requirements. So I am talking about the regular faculty members. So I mean to say the instructor is definitely belonging to a department for sure. And that is why all the instructors will be definitely working for a department. And that is why the participation is a total participation. All right, we have established the relationship between the instructor and the department. We also know that we are going to establish the relationship between the student and the department. What is that? Definitely, student and department are also associated with each other through student-department relationship. You can give any names as per the requirement. As already mentioned, for generic notation, I am just giving student department as the relationship between student entity and the department entity. Now, what is the relationship? This is also definitely a one-to-many relationship because a department may have many students, but a student must be belonging to at most one department. And that is why the relationship student-department is a one-to-many relationship. And what about the participation constraint here? This is also having a total participation because all the students will be definitely belonging to some department. So all the students will be participating in this relationship with the department entity. I hope things are clear to you now. University is not limited only with these entities. We have a lot more entities. Let's see the next entity, the section. Now, when we talk about this section, again, an instructor will be handling course for a particular section, as well as a student will also be a part of a section, isn't it? So in this case, we have a section entity where both instructor and student are going to be related with each other. At first, let's focus on what is the relationship between instructor and section. The relationship is teachers. Obviously, instructor is going to teach to a particular section, and that's why we have a teachers relationship. So instructor and section are related with teachers relationship. So instructor, teaches section. And also, if you note here, this is a total participation because if you have a section, definitely that section will be engaged in the teaching process with a specific instructor. And that is why it is a total participation. If you observe, we have one-to-many relationship here, here, as well as here. I mean, advisors, instructor department, student department, all three have one-to-many relationship. What about this? This is definitely not one-to-many because we have no arrows represented here. So the relationship here is a many-to-many relationship. Many instructors may be engaged with many sections. And that is why we cannot go for or think about one-to-one or one-to-many or many-to-one. In a generic way, it is a many-to-many relationship. We are done with establishing the relationship between instructor and the section. How? Using teacher's relationship. Now coming to how section and student are related to each other. Takes. Students will be taking a particular section, or a section will be having a set of students. So obviously, I am representing it with the takes relationship. And what kind of relationship? Here there is no total participation. However, it is many to many. Now you may be asking why I have given a dotted line for this section ID attribute. If you see the section entity that contains three attributes, section ID, semester, and year, there is no primary key here. In fact, section ID, semester, and year, all three together should form a key. In simple terms, there is no primary key attribute in the section entity. Of course, you can have dashed underlines for all three. I mean section ID, semester, and year. Now, one more interesting thing here is when we say student and section has takes relationship, obviously, the student has student ID, name, total credits earned. Obviously, students will be belonging to a particular section that has a section ID, semester, and year. So in this particular semester and year, what is the grade that student has taken? So this relationship should reveal or should hold information about the grade related information. So what do we mean by this? It means this grade is an attribute that is attached to this relationship set, which is actually takes relationship set. This way of representing thing is known as attribute associated to a relationship set. Takes between student and section is a strong relationship. In all the cases, everything is a strong relationship because there is at least one primary key attribute in each of this case, except section entity. Now let's build this ER diagram furthermore. Let me bring in the course entity. What do you mean by this? Obviously, in a university, there will be a set of courses where each course is identified using course ID. Each course will have a title and the maximum credits information. So course entity will have course ID as the primary key attribute, the title of the course, and credits. For example, 301 database management system with the credits of 4. So 301 meaning the course ID, title is database management systems, and the credits is 3 or 4 as per the university. As you are aware, all these are requirements based. So we can say course is also an inevitable entity in the university database. Now, when we talk about course, each department will have their set of courses. So this has to be related to the department relation. I mean, the course entity should be somehow related with the department entity through some relationship. Also, when we talk about section, each course should be associated with the section as well because the sections are already associated with instructor and the student. So student will be taking the course by enrolling into a specific section, isn't it? So after they are enrolled into the section, they will be opting for specific courses. Similarly, courses are offered by the departments. At first, let's see the relationship between this course and the section. The relationship between course and the section is this section course relationship. Now, if you see, this is a double diamond. What does double diamond mean? It means it is a weak relationship, isn't it? Now, what kind of participation it is? A total participation. And what kind of mapping cardinality? It is one-to-many mapping cardinality. And also, if you observe here, this is not a primary key attribute. Very, very important. Please make a note of this. Since we don't have a primary key attribute, anything in the section relationship that uniquely identifies things, and that is why this entity we refer as a weak entity. So the relationship between one strong entity, course, which has a course ID as the primary key attribute, with the another entity which is not having a primary key attribute, and that's why the relationship that is formed between this course and the section entity is a weak relationship. Now let's see the relationship between this course and the department. Obviously, course is also associated with the department with course-department relationship, and this is also a total participation, which is a strong relationship. Why? Because this is associated with two strong entities, department and course ID, which has their own primary keys. And that is why this relationship is a strong relationship. Whereas here, this is a weak relationship. Let's build this ER diagram furthermore. Let's bring in the prerequisite relation, which is this. What do we mean by this? You see, this is a unary relationship. This is not a binary relationship like others, whatever we have seen. A binary relationship which is actually associated between two entities. This is a binary relationship. This is a binary relationship. If you see all other relationships, whatever we have discussed so far, except this prerequisite, is a binary relationship because they are associated with two tables or two entities. If you see here, this prerequisite relationship is actually a unary relation because it acts only on the course table. Why? Because we are going to represent two roles here. What are the roles? The course ID and the prerequisite ID. Let's assume this scenario. If students wants to enroll in Java, before taking the course Java, students should have at least some object-oriented knowledge. And that is why object-oriented programming may be a prerequisite course. So if you see here, this prerequisite is the relationship that deals with only one entity, which is course, where object-oriented programming course is also available here. Java programming course is also available here. Let's take another example. If students wants to enroll in cryptography and network security course, obviously they should have the strong fundamentals about computer networks. And that is why we can say computer network course should be a prerequisite for cryptography and network security. All these relationships are existing inside this single entity. And this relationship is a prerequisite relationship which deals with only one entity with the roles, course ID, and the prerequisite ID. For example, cryptography and network security course ID should be linked or associated with the prerequisite ID of computer networks. I hope things are making sense to you. Let's build this ER diagram furthermore. Now let's bring in the classroom, which is an entity. This classroom will be in a specific building with the room number and the capacity. Because when we think about real-world entities, these things are inevitable, isn't it? A classroom is also a real-world entity which is described by building or building number, room number, and the capacity. Now, each section needs a class, isn't it? Now let's establish the relationship between section and the classroom. So the relationship is actually section-class relationship between a section and the classroom. And what kind of relationship it is? It's again one-to-many relationship. Relationship section-class between section and classroom is having a total participation. All the sections will be having a classroom, and it's a one-to-many relationship. Now let's bring in another entity, the time slot, where time slot ID is a primary key attribute which is described by other composite attribute, day, start time, and end time. As I mentioned, these are all requirements based. How this time slot is associated with a specific section, which is through section time slot, and what kind of relationship it is? It is a total participation with one-to-many relationship. I hope things are clear to you. If you observe this whole ER diagram, this gives the overall logical structure. In other words, we can say this is a graphical representation, which is easy to implement. If a database administrator sees this, he knows how to construct the database with the database softwares. It may be any software, but he or she knows that there should exist an instructor entity with these attributes, department entity with these attributes, and how they should be related to each other, and what kind of participation it should be. what kind of relationship it should be established, whether it is one-to-one or one-to-many or many-to-one or many-to-many. Similarly, what kind of participation as well, whether it is a total participation or partial participation, and what kind of relationship as well. In the whole picture, if you see, there are multiple relationships. One is a unary relationship as depicted here. Other things are binary relationship because it's acting on two tables or two entities. I hope things are clear to you. Again, I want to emphasize this is based on some assumptions. Now, there is a homework question for you. Just keenly observe this, and according to you, what are all the assumptions that we have made here? I'll give you one assumption. Here, I have assumed that instructors will be all regular faculty members or regular instructors. There are no part-time or guest faculties or adjunct faculties. Here, all are full-time faculty members. So this is one assumption I have made here. Just correlate this with your university database and find out what are all the assumptions that we have made here, or in other words, how this university database is differing from the actual logic which is implemented in your university or in your college. Draft a paragraph about this and post your answers in the comment section. I hope the session is interesting. I'll see you in the next presentation, and thank you for watching.